All right, good afternoon. Gonna wait just a couple more minutes to give everybody about 2 more minutes to log on. And then we'll get started for today. All right, so for today's lesson, day 6, we are going to work on solving radical equations. So we have 4 steps in order to solve a radical equation that has 1 square root. The first step is to isolate the radical on one side of the equation. It doesn't matter which side, as long as it's isolated by itself. Once you have that task completed, you're going to square both sides of the equation to cancel out that square root. Step 3, we're going to solve for the variable. And then last step, we need to check our solutions. So looking at the problem over on the right-hand side, step 1, we want to isolate the radical. So when I look this here, I want to get this by itself first. I want nothing else on the same side of the equal sign as that radical. So first thing I've got to move is this -5 by adding 5 to both sides. For step number 2, we're going to square both sides of the equation. So we're going to square the left side and we're going to square the right side. When we square the left side, the square root and the squared are inverse operations and they're going to cancel each other out. We're just left with what's underneath the radical, which is the x plus 3. On the right-hand side, we have 5 squared. 5 squared means 5 times 5, which is 25. Now we want to subtract 3 from both sides to get an answer of x equals 22. Now, before I circle my answer, I want to check my solution. So I'm going to label this check. And then underneath it, I'm going to go all the way back to the original. So the original was the square root of x plus 3 minus 5 equals 0. I'm going to plug in the x value of 22. So I'm going to have the square root of 22 plus 3 minus 5 equals 0. So then I'm going to take 22 plus 3, which is 25. So I'm going to have the square root of 25. And some of these steps you can condense into one step. So like the first line, I wouldn't have wrote that down because that's just the original problem. You can do a lot of this check work in your head. But remember, for your final exam, you want to show all work possible. Don't skip a bunch of steps because your final exam will be on paper. You'll have to take that with somebody in your building, and then they'll send them over to me to be graded, and then I have to send them on to IB Tech. So anyway, square root of 25 is 5, and then we need to confirm, does 5 minus 5 equal 0? Well, yes, absolutely. So this x value of 22 is a solution. So I'm going to go back, I'm going to circle it, I'm going to box it in because it is a solution. Questions on this first one? All right, we're going to move to question 2. So example number 2 still has one radical in it. We're still going to use those same 4 steps in order to solve. So step number 1, we're going to isolate the radical. Right here is our radical. We want to get rid of anything that's in front of it, underneath it, or hanging out behind it. In this case, we just have the 1 to get rid of. So subtract 1 from both sides. And that's going to give us with 2x plus 3 equals 5. At this point, we've isolated our radical. We want to go ahead and square both sides. So putting both sides in parentheses and then squaring them. In this case, your square root and your squared are going to cancel. You have 2x plus 3 on the left-hand side and 5 squared, which is 25 on the right-hand side. Now we have a multi-step equation in which we need to solve for x. So in order to solve for x, we are going to subtract 3 from both sides. It's going to give us 2x equals 22. Divide it. We're going to divide both sides by 2. to get an answer of x equals 11. So now we need to jump over to the side to check our solution. So again, we're going to go all the way back to the original. And in the original, I'm going to plug in 11 anywhere I see our variable. Now I'm going to start simplifying. I'm going to take 2 times 11, which is 22. I'm going to go ahead and take 22 plus 3 to get 25. Now I know that the square root of 25 is 5, so really the left-hand side is 1 plus 5, which does indeed equal 6. So 11 is a solution. I'm going to go back and circle it, box it in, somehow show that that is my final answer. Moving down to the next question. Again, we have one radical. We have 4 steps we need to complete. First step, isolate the radical on one side of the equation. That is actually already done. The square root in this case is on the right-hand side. There's nothing else on the right-hand side with it. So this one, you get to skip that step right there. So then we're going to jump to step number 2. Step number 2 is to square both sides of the equation. So now that we've squared both sides of the equation, the right-hand side is the simpler side. The squared and the square root are going to cancel each other out and leave you with x plus 10. The left-hand side, however, when you square a binomial, it's a binomial because there's 2 terms here. That really means you need to take x plus 4 and multiply it by itself, x plus 4. So there's a couple different ways you could actually do that multiplication. I have a lot of students that I teach here that like to use the box method, and we've talked about it before. So the x plus 4 times the x plus 4. When I was in school, I was taught a completely different way, but this way is just very organized and easy to follow along with. So we're going to keep with this. When I fill out my box, remember, we're going to multiply corresponding parts. So if I'm looking in the top left box, I'm going to look up and see x, look to the left and see x, and I'm going to multiply x times x to get x squared. For the top right box, I'm going to look up and see 4. I'm going to look to the left and see x. 4 times x is 4x. For the bottom left box, 4 times x is again 4x. And then last but not least, that bottom right box, 4 times 4, which is 16. So x plus 4 times x plus 4 is actually going to equal x squared plus, I'm going to combine like terms here with the 4x and the 4x. So I'm actually going to write 8x and then plus 16. So I've combined like terms there with the 4x and the 4x. Next thing I'm going to do is move everything to the left-hand side. So subtract x. Then you want to subtract 10. If you're confident in math, you can do both of those at the same time. To get the quadratic x squared plus 7x plus 6 equals 0. Now we want to go ahead and factor this. So we're going to factor using the asterisk method. If you know how to factor other ways, please go ahead and do that. So asterisk method says A goes in the top left, top right of your asterisk. So we have 1. B goes to the bottom middle. So 7 goes to the bottom. And then A times C, or 1 times 6, which is 6, goes in the top middle. Now we're looking for 2 numbers to fill the voids. They have to multiply to give us 6, but add to give us 7. So those 2 numbers are going to be positive 6 and positive 1. So that means I have factors x plus 6 and another factor x plus 1 still equals to 0. Now that we have our 2 factors, we're going to go ahead and set our factors equal to 0. So that 0 product property allows us to set our 2 factors equal to 0. And then we're going to go ahead and solve both of those for x. So the first one, subtract 6 from both sides to get x equals -6. We're going to subtract 1 from the second one to get x equals -1. Order doesn't matter. If you have -1 on the left and positive 6 on the right, that's fine as well. So now this time we have 2 answers, which means we're going to have to make our checks twice. So we're going to have to check both solutions. And again, you want to go all the way back to the original when you check. So we're going to plug in this case, I'm going to start with -6. So -6 plus 4 equals the square root of -6 plus 10. And then I'm going to simplify that. I'm going to simplify the left-hand side. And I'm going to simplify the right-hand side. So on the left-hand side, I'm going to take -6 plus 4, which is -2. On the right-hand side, I'm going to take -6 plus 10, which is 4. And then we know that the square root of 4 is 2. So we need to ask ourselves, does 2 equal -2? Are those the same? Well, no, absolutely not. So 2 does not equal -2. So we put a little slash mark through that equal sign saying, hey, 2 does not equal -2. What that means is that this answer right here is what we call extraneous. So we didn't do anything wrong. We solved the problem correctly. We just got an extra answer. So you see how extra is in the word extraneous. It just means, hey, that's an extra answer. It didn't work when we checked it, and this is the reason why we have to check them. Now we're going to go ahead and check -1. So -1 plus 4 equals the square root of -1 plus 10. And again, we're going to simplify the left-hand side and the right-hand side separately. So I'm going to have +3 equals the square root of 9. Square root of 9 is 3, and we can confirm that 3 does equal 3. So that one checks. So I can go back and circle or indicate that -1 is a solution. Questions on this one? So take a minute and see how far you can get on this problem before I go over it. So I'll give you a couple minutes to work on it, and then we'll go over it together. All right, so first step, we should isolate the radical. So in order to isolate our radical, we need to subtract 4 from both sides. So that's going to give us the square root of x plus 2 on the left-hand side and x minus 4 on the right-hand side. Oops. Now we want to square both sides. On the left-hand side, the square root and the squared cancel, they're inverses, leaving us with x plus 2. And then on the right-hand side, to make sure you multiply x minus 4 times x minus 4. So if you draw yourself a quick box out to the side, you're going to get x squared minus 4x minus 4x and positive 16. So if I go back to the problem, I'm going to have that x plus 2 still on the left-hand side. On the right-hand side, we're going to have x squared minus 8x plus 16. From here, I want to move everything to one side. So I want to subtract the two terms from the left to move them to the right. So I want to subtract x and I want to subtract 2. So that gives me the quadratic x squared minus 9x plus 14. Looking at this quadratic, I'm going to jump over to the asterisk. I'm going to have A in the top left, top right, B in the bottom middle, and then A times C in the top middle, 1 times 14, which is 14. So now my mission is to find two numbers that multiply to give me 14, but add together to give me -9. So those two numbers are going to be -7 and -2. Order doesn't matter as long as you get them both. So now I'm going to have factors x minus 7 and x minus 2. Now that I have my two factors, I can use the zero product property and say, hey, I have two factors being multiplied together, and that product is 0, so one of them must equal 0. So that gives me two possible answers, x equals 7 and x equals 2. We cannot just assume that they both work. We need to plug them both back in to check them. So take a minute and go back and plug in 7 into the original and see if you get a true statement or a false statement. If you get a true statement, then 7 is a solution. If you get a false statement, then 7 is extraneous. All right, so for the check with 7, went ahead and plugged in 7 into the original equation. It's going to give us the square root of 7 plus 2, which is actually the square root of 9. The square root of 9 equals 3, so 4 plus 3 equals 7. We should all know that is a true statement. 4 plus 3 is 7, so 7 equals 7. That means that I can go back to 7 and circle it. It is a solution. You cannot just automatically say that 2 is extraneous because sometimes you have 2 answers that work. So sometimes both answers will work. I believe there's a question on your assignment today that both answers actually end up working. So be on the lookout for that. In this case, we're going to have 4 plus the square root of 4. Well, that's going to be 4 plus 2, which does not equal 2. So in this case, for this problem, this answer is extraneous. When you're doing your homework this afternoon, please note that when you enter your answers for a problem like this, you would only enter x equals 7 because that's your only final answer. Yes, we got an answer of 2 along the way, but we showed that it was extraneous, so it's not part of the solution. Last one, my favorite kind, have 2 roots in them. So when you have 2 roots, you have a radical on the left and a radical on the right. Make sure that one's on the left and one's on the right. And then you want to square both sides of your equation. So I'm going to go ahead and take this equation and I'm going to square it. Well, great things happen when you square both sides of this. The square root on the left with the square are going to cancel, leaving you with 9 minus n. And then on the right side, the squared and the square root cancel each other out, leaving you with 16 minus 2n. There's no quadratic here because there's no n squared. So all you need to do is get your n's together and solve for that n. So I would, if I was solving this, add 2n to both sides. That would give me 9 plus 1n equals 16. Subtract 9 from both sides to get n by itself. And n equals 7. When I check this one, I'm going to have the square root of 9 minus 7 equals the square root of 16 minus 2 times 7. Again, I want to simplify the left-hand side and the right-hand side individually. So on the left-hand side, 9 minus 7 is 2. So I have the square root of 2 on the left. On the right-hand side, I have 7 times 2, which is 14. 16 minus 14 is 2. So now we have the square root of 2 equals the square root of 2. Well, the square root of 2 does equal the square root of 2. So n equals 7 is a solution.